Solve systems of equation using matrices. Use matrix to solve this system. Well, you are familiar with these set of equations. We have done it in a separate video. But here, the idea is to explain the process, how to use matrix to solve equations. And at present, that is my main concern. I really want my students to adopt this method. It is extremely efficient way of doing, and it saves lot of time. And even if you make a mistake, you can go back, check it very easily, and get back to the answer fast without wasting much time. It is extremely important for you all to understand the method and apply it. Okay, now here I will explain you most of the time what I am trying to do, rather than rushing towards the solution as I sometimes do in my videos. Okay. Now let me tell you what a matrix is, kind of, right? So matrix is a rectangular array of terms called elements, which has rows and columns, and it has square brackets on it. So let me just give a structure of that matrix here. So something like this. That is what I'm saying with a bracket like this. Rows and columns, you'll have things here like this. Now we have three equations here. So our three equations which are on the left side can be represented by these three 3x3 dots which I've put here, and these dots are my elements. Okay, and what I'm calling rows are, so if you see from this side, so these are my rows, right? So the rows are here, right? These are my rows, and we label them like R1, the row number 1, R2, row number 2, and R3 as row number 3. Now these rows are representing my equations 1, 2, and 3. Now in matrix, it is very important to see that rows are not fixed. You can interchange them, right? So we could interchange our equations. Correct? We could write this equation first. The system remains the same. That's the whole idea, right? The system remains the same. Whether I write this equation first or that, it is one and the same thing. But when we are solving system of equation, selection of first equation is most critical, because as you will see later, most of the operations are done with the help of first equation, and first equation normally is not changed at all. It is just kept as such. So for me, the third equation is extremely good to put in the very top, right? Since it has got all ones, and I can easily multiply, divide, and use my operations and then reduce the matrix to get a solution. But the current first equation is not bad either, since we are most of the time worried about the x and y value, and we want to make them 0. I'll tell you the strategy later, correct? But at present, it seems to be okay for me. Now, one critical thing which I will tell you is, in case the equation is mixed up, what I'm trying to say is x and y's all don't have may have a 0 coefficient, right? So there may be some missing terms in between, or we may have constant terms on the left side of equality, correct? Think about an equation like this. If I have equation like x minus 2z plus 5 equals to 0, then I'll prefer you to write this equation with all the three variables as x plus 0y, okay, minus 2z equals to minus 5. So that is also a step which is very critical. Reorganize your equation, and that is, I will say, first step before even filling in values in the matrix. So first step will be, we'll say reorganize. Equations. Okay, so you understand what I mean by reorganize equation. Put all the constant terms on the right. So here, what do we have? Here we have constants, and on this side of the matrix we have the variables, right? So the terms with variables. So we say we say coefficients with variables. Okay, so these are the coefficients, right? These are the coefficients. One is the coefficient of x here. So these are, I'll say this is my left hand side and that is my right hand side of equality. Correct. Now, so this is what we have, and that is what I'm going to translate on my matrix. Now, when we use matrix to solve equation, we kind of change it a bit. So we call that as an augmented matrix. So what I'm trying to write here is an augmented matrix. So let me write that. So that means a change matrix, right? And that helps us to solve the problems. And how do we change it? This equality sign, we draw a line here and then close the bracket. So the matrix, which could have been 3 by 3, now has become 3 by 4. So we have this as a 3 by 4 matrix, right? So why 3 by 4? We still have 3 rows with us, but we have 4 columns. 1, 2, 3, 4. Okay. So that is kind of critical at this moment to understand. Now what do we do? So on the left side of this straight line, we'll put the coefficients of all the variables, and these coefficients should come in the columns in proper order. That is very critical. You can never change the order of the columns, okay? Now while solving these equations, fine. So we'll do this. So coefficients are minus 1, 1 and 5. So I'll write minus 1, 1 and 5. This is my first equation. Equal to is this line kind of, and then we have 0 on the right side. And then we have 3, 2, 5, 5. So I'll write 3, 2, 5, 5. And the last row is 1, 1, 1, 2. So we have 1, 1, 1 and 2. So as you see, we have got only coefficients now here, and the variables are assumed, right? They are in order, and the order is x, y, z. So this represents x for us, this is y for us, and this is z for us, correct? So those are the columns, and these are constant values. Let me say k, the constant values, on the right side of equality. So the first step has been done for us. We created augmented matrix from the given systems of equations. Now, how to solve and get the answer from it, right? So that is where matrices help us a great deal. So the steps to solve is to follow some rules. So we call them elementary row operations, okay? So let me put some elementary row operations here. So the term used will be elementary row operations. What are these operations, and what can we do about? So first thing what we can do is we can always multiply or divide any row by a constant term. So what we can do is we can multiply or divide by non-zero, I should write here, very important, non-zero integers, you can say, right? Non-zero numbers, let's say real numbers, non-zero real numbers, okay? So real numbers. So we can multiply, divide by non-zero real numbers, all the terms in a row. That is what we can do. And once we do that, we can add or subtract. So these modified, so they become a modified row for us, correct? And that results to a modified row, right? Modified row, but still represents the same. It's equivalent. It's think like this. If I write x plus y plus z equals to 2, and if I multiply by 2, I get 2x plus 2y plus 2z equals to 4. It is the same equation, correct? So because we are doing it on both sides of equality, equation remains the same. So it's modified, but it is equivalent. So it's an equivalent row. It represents the same equation, right? But the help we get from it is that we can add or we can add this, whatever modified this, we can add this row to our any row. If we can add this, I should say equivalent now, row to any row, right? And simplify. So I'll show you what I'm trying to say here, and that is where the strategy comes. So let me write down what my strategy is to solve the problem. Okay, so this is the operation which I can do. So the rows, add an equivalent row to any row and simplify, and I can say that simplify replaced row. Okay, so we have a replaced row, which is also equivalent. I should say equivalent. Okay, equivalent is critical word here. Okay, now to do all this, what kind of strategy are we following, right? That is what we need to understand. So the strategy being followed is kind of like this. Look at the matrix like this, right? And we have, let me make something here so that I can tell you what I'm trying to do, right? So let's say we have some matrix here, and you can see all the numbers. So what I'm trying to do is I have these numbers here, correct? These numbers here, correct? I have these numbers, correct? All these numbers. What I'm trying to do, I'm trying to make zeros here in this corner. In that case, so if I make zeros in this corner, then that represents my z value. So z is equal to that value. Once I know z, I can use that equation. Y and z equals to something, right? So I will substitute, we call it back substitution. I'll substitute z here, find y. Once I know y and z, I can find x. So that is the back substitution, right? Back calculation, which will help us to find the values of our variables. So that is the strategy we are looking forward to, correct? So now let's get back to solving our problem, right? So let me summarize what I did here, right? First thing what we did is we wrote on this side the coefficients, right, of the variables. So this side, all these are coefficients of variables, right? Coefficients of variables, right? And on this side we have constants. Is it okay? Which are on the right side of equality, and that is, these are the coefficients of our variables. Okay, all these. So this is what we wrote, and we got which is being called augmented matrix. And now what we are going to do is we are going to do a process which is called row reduction, right? So strategy is to do row reduction, okay, by doing these elementary row operations. So that is the strategy, row reduction. And how are we going to do row reduction? That is our aim. That is the objective, to get these 3 zeros in the corner. Okay, so let's do it. So let's draw this matrix once again and see how can we simplify it. Now here I want to make a 0 here. How can I do that? Well, if I add row 1 and row 3, I get a 0. Perfect. And as I said, row 1 normally doesn't change. So first thing you should always do is write down the row 1, so that you get your structure back, correct? And it helps to fill in all other values. Is that okay? So we'll start from this corner. So here what we will do is we will add R1 to R3. So that is how we write. So we have to write what we are doing so that we can check what we have done, right? Now we do R1 plus R3. So if I do, that means adding this to this, this to this, this to this, this to this, and writing our new values. And that is what I'm saying is a modified replaced row, correct? So when I do that, I get a 0 here, 1 plus 1 is 2, 5 plus 1 is 6, and 0 plus 2 is 2. So this is my row 3, which is now modified and replaced with 0, 2, 6, 2. It is equivalent to our system. The system's solution is not changed. Yes, the matrix has changed. Now, second strategy is I want to make that 0. Now, how will I make row 2 column 1 0? Row 2 column 1. It can be made 0 if I multiply third row by 3, right, and then add. So that means I'm trying to do 3 times R1 plus R2, right? So I do that, and 3 times this is minus 3 plus 3 is 0. 3 plus 2 is 5. 3 times 5, 15 plus 5 is 20. 3 times 0 is 0 plus 5 is 5. So we get this second step, correct? But in just 2 steps. See what we have done. We have done great stuff. We reduced the equation to we eliminated x from 2 equations, right? Do you see that? Now we have y and z, and you can always solve for y and z and get your answer. But we'll go a step further, and in this step we will reduce this to 0. That is what we want, and that is the row reduction. Row reduction does not mean reducing from 3 rows to 2 rows or 1. It means simplifying, basically. Okay, the term is like confusing. Anyway, so let's make this matrix right on our first row as such. That is easy to do, correct? And now, how can we change this row? We can multiply the second row. Remember, at this stage, because we don't want to disturb the 0, so we cannot use the first row, okay? We should use the second row. That is kind of critical to think. Now, so we have to use second row and the third row to get this 0. So we should multiply this by minus 2 over 5. Is that okay? Minus 2 over 5 to get our answer. Then we can do it, right? So that is kind of fraction. What we could have done also, we could divide this row by 5 as such, because 5 is a common factor. Then in that case I get 0, 1, 4, 1, and then multiply by 2, right? Minus 2 rather, and add this, correct? So we could have done in 2 steps, right? So you should do like that, but at present what I'm doing, I'm running out of space, and therefore I'm doing this step here and using fractions, okay? So I'll multiply the second row by minus 2 over 5. This is my second row getting multiplied, and then I'm adding the third row to it, okay, which is R3, right? So I'll do this operation and do it. 0 times anything is 0. When I add 0, I get 0, right? Minus 2 over 5 will lead to minus 2 here. Minus 2 plus 2 is 0. Now here if I divide 20 by 5, I get 4, and 4 times minus 2 is minus 8. Minus 8 plus 6 is minus 2, right? So we get minus 2 here. Now here we have 5 divided by 5 is 1, and minus 2 is minus 2, and minus 2 plus 2 will give me 0, correct? So we get 0 here. So that's what we get here. Now this row, as I said, you could actually divide the row by 5 and write a simplified row, correct? That is all up to you. So let's do it, and we can replace the row by, so we can say this row is R2, and we divide R2 by 2 by 5 and write it, correct? So I'm writing R2 as 1/5 of R2, correct? So when I do 1/5 of R2, then I get 0 here, and 5 divided by 5 is 1, 20 divided by 5 is 4, 5 divided by 5 is 1. So I kind of get this kind of a simplified equation. Now see the beauty of this. Now we'll go back. We'll do what we did the first step. We'll redo it. So what is that back step? Now these, you remember, are the coefficients of x, y, and z, right? So this is kind of 0x plus 0y minus 2z equals to 0. Is that okay? So I can write here as, translate this, right? So I don't have to write 0x and 0y, but I can definitely write minus 2z equal, sorry, this was not 0. Let me see, 1/5 of this was 5 minus 2, yeah, it is 0. So minus 2z is equal to 0, right? So that is my equation from here. And the equation from this place is y plus 4z equals to 1, correct? And if I translate row number 1, I get minus x plus y plus 5z equals to 0, right? So these are my three reduced equations, right? So that gives me the result that z is equal to 0. Now, if I put z as 0 here, that gives me y equals to 1, correct? And if I put y equals to 1 here, right, and z as 0, I can solve as x equals to 1. Do you see how efficiently we move from here to here and from here to here? Do you see that? So we get our solution, and that solution is x equals to y equals to this. So row reduction leads to a solution, right? So that is a solution, right? So what is the solution for us? The solution for us is x equals to 1, y equals to 1, or z equals to 1. Do you see that? So and it was so easy to get, just 3-4 steps and you get hold of your solution. Now you can check your solution. How will you check? If I put 1, 1 and 0, do I get this term? So yes, we do, right? If you sub in 1, 1 and 0, yes, you get minus 1 plus 1 is 0. 1, 3 plus 2 is 5, yes, z is 0 for us, and 1 plus 1 is 2. So that solution check is done, right? And perfect. X equals to 1, y equals to 1, and z equals to 0 leads to the solution. So I hope you appreciate the way we moved around and simplified and got our job done so neatly in such a less time. Okay, so remember, first step is always, when you look at an equation, equations could be like this. Equation could have missing terms. In that, fill in the terms, write all the constants on the right hand side, write all the terms in proper order. That means x, y, z kind of, right? Proper orders of the variables, and then translate them into augmented matrix. In augmented matrix, we'll have the coefficients on the left side of the line. Line represents kind of equality, and on the right side we have the constants. So put them in order. Rows can be interchanged. I could have interchanged and write row 1 in place of row 2 and row 2 in place of row 1. But important thing here is row 1 should be such a simple row which could be easily multiplied and divided with numbers and help us in simplifying the other rows. All the row reduction process is because of elementary row operations. Elementary because we are just doing simple operations of addition, subtraction, multiplication and division. Nothing more than that, right? So of course you cannot multiply by 0 on both the sides. Now when you do these operations on a row, then it can be added to the row which you need to modify. That is important. We needed to modify R3, right? So we added R3 with our operations on the other row. For example, we did 3 times R1 and added it to R2. So when you're trying to add, avoid doing any operation on the row which is being modified. Important, okay? Only do operations on the other row which is helping you to reduce the current row, okay? Don't do operations on the current row, and always just add the row, okay? Avoid subtract. I could have done multiply by 2 over 5R2 and minus R3, but avoid that, okay? Just make it a rule. Just add to the row being modified. That's why I'm using the word add here, right? It's not a rule. Add and subtraction is the same thing, correct? So add this equivalent row. Equivalent is kind of critical. Row doesn't change if you multiply and divide both sides by the same thing because it's an equation, correct? That's why it doesn't change. And then you simplify. And the strategy, as you've seen, is to get these 3 zeros in the corner, the right hand corner at the bottom, right? Once you get that, then you can do the back substitution and get your answer. So that is kind of, so you do reverse, or you can say back substitution, right? To get your answer. And that's how beautifully you're done. Do you see that? So you get the value of z from the last equation, then the value of y from the last and last but one, that means row 3 and 2, and then the value of x using the values of y and z. And I hope you appreciate this process and you like it. Please do put your comments, and if you still have any doubts, get back to me, right? We'll find a way so that you start using matrices to solve systems of equation. You'll really love it. All the best. Thank you.